Okay, awesome. So I'm going to first go over the add binary solution, and that, so like the way that I approached it, there's like multiple ways to approach it. Like I said earlier, you could, like, you know that you're given strings A and B that represent binary strings. You could convert those to integers, add the integers using the plus operator, and then convert those integers to a binary solution. So like that's like the like the answer that was set in the chat earlier. If y'all were there for that. And like the issue with the solution is if you had like a super large binary string, like I don't know, I feel like that's pretty big. And it'd be like if you try to convert this to an integer, and an integer, or like into a number that only has a certain amount of bits that it can represent an integer as. So for example, it'd usually be like 32 bits is the max for an integer. If this was like more than 32 bits long, then like it would have some overflow in like converting it into a decimal number. And when you add decimal numbers, it wouldn't give you the same result. So like a different way to do this is just like not to change the string itself, but like just um, like use the properties of binary addition on these strings and find the solution at each iteration of like comparing the two strings A and B. So the way that I approached this was I first reversed A and B because like the way that I wanted to iterate both of the strings A and B was from right to left, because that's like when you add from right to left as well. So that's why I do that first. I get the lengths of them, and I know that like at each step you'll have like the result at that step, and as well as a potential carry that you'd have to store. So like in this example, like 1010 plus 1011, I'll add like a comment here. Like adding these two would mean that like at the end you do 0 plus 1, and then there's no carry. The carry is 0, but the result of this step, 0 plus 1 is 1. And then at this step you do 1 plus 1, which gives you 0 with a carry of 1. And then you use that carry in determining the next part in the sequence. So like 1 plus 0, 0 gives you a 1 at that spot. And then like there's no carry from there, but then this 1 plus 1 gives you a 0 with a carry of 1 again that you have to like include. You have to include an extra bit in the answer, and like that's the answer that you're trying to get. So like you'll have something that you have a variable to store the result for each step, and then a variable that like stores and updates the carry based on like comparing the 0 and the 1, or comparing the binary numbers at that step. So while you're going through string A and string B, you like first I have something that stores the sum. Like it first like adds whatever the carry is to it, and then adds like I like convert like the binary number, like the character at the position of that string, into an integer, and I like physically add it to 1-bit sum for like the current integer, the current character in A, and then also for the current character in B, and like the I plus equals 1 and J plus equals 1 is to so that I can like iterate through A and B while I add them. So like I add the carry, the character at A, and the character at B in int form, and I store that in 1-bit sum. And then like the actual result, that's the number that's at that point is 1-bit sum mod 2, because if you have a situation where it's like you're adding 1 plus 1, the sum is 2, and you want like the result at that position to be 0, but with a carry of 1. So it'd be like the number 2 mod 2, which is 0 in result, and then you'd store the carry as 2 divided by 2. This like double slash means that you're discarding the remainder. So if 1-bit sum was like the number 3 and you're dividing it by 2, it would just store the number 1 and it wouldn't calculate like 1.5 or anything. But if 1-bit sum was 2, you want the carry to be 1. And so the carry is 1 for that case. And so you're like incrementing through and you're like adding the carry at each step. And then and then once you're out of this loop, like you've compared every like element of both of the binary strings, you might, if your carry is 1 there, so like in the example from above, like there was like a carry like after you had compared each element separately and you want to include that in the answer, you would like add that to the string result, and then I return results, but reversed, because like I had reversed the strings before to iterate through them in the order that I wanted to, and then I have to like, so I'm actually like the value that I'm calculated is in the reverse order in the binary string, so I have to return the result backwards to get the actual binary number that I want to represent. Does anyone have questions on that? Okay, feel free to reach out if anything is unclear. But I know that the second problem, the harder one, it is pretty hard, and I honestly don't know how to do half of it, but I will tell you the part that I do understand. So this problem is like using bit manipulation to calculate the sum of two integers, a and b, without using the operators plus and minus. So a and b could be positive or negative numbers, and you just don't want to use these two operators. So I do understand the part where you add them if they're two positive numbers. So like the way that works is like following suit with the algorithm that I described before, that like compares the two values from right to left of two binary strings. Like you have to find the result in the carry, and you keep shifting the carry over and adding that as well. So like a way that you can simulate the adding of two binary numbers without using that like doesn't take into account the carry is doing an Xor operation. So an Xor comparison is like signified with this caret sign and in code. And so when you like you XOR like one string with another, or when you XOR one binary number to another number, or even so like one integer, because like integers are stored in binary in a computer. What that does is at the bit level, it will compare, like for example, these two binary, like these two numbers representing 15 and 2 in binary. If you XOR them, you compare, you return a 1 if the two numbers at the same position that you're comparing them at are different. You return a 1 if they're different, and you return a 0 if they're the same. So 1 at this position, the last one XORed with the last 0 should be a 1 because they're different. But a 1 XORed with a 1 is a 0 because they're not different. And then like a 1 compared to a 0 returns a result of 1 if you XOR them. So like that works because it's like if you're like, you do know that like when you're adding in binary, like 1 plus 0 should be 1, 1 plus 1 is 0 at that point, but you have a carry of 1 that's just added at the next step. And so then the way that you incorporate that carry is additionally, like you can get, like if there's a carry at one step, if a carry is produced at one step, you can get that by ANDing the two numbers x and y. So if you AND numbers at the bit level, you get it so that you return a 0 if both numbers are not 1, and you only return a 1 when both numbers are 1. So like 1 ANDed with 0 gives you a 0. 1 ANDed with 1 should give you a 1. 1 and like both of these should give you 0, and 0 ANDed with 0 should give you a 0. And so, but the thing is, when you incorporate the carry again, you actually want to add it at the position that's shifted 1 to the left from where you're comparing those two numbers. So so in this example, you know that like 1 plus 1 should give you a 0 with a carry of 1. And like what the solution does is it ANDs them, and where in the one that's returned from the ANDed expression would be in like this position, right? But you want it to be in that position. So the next time you XOR them, it compares a 1 with a 1 and gives you a 0, and then like continues to carry the 1 over. So that's why you shift it you shift the carry, or you shift this operation 1 to the left so that you're comparing it in the correct position. And so like the way that they sum two positive integers is they XOR them, and they do it so that like they check that like what they store in this carry, as long as it's not all zeros, it will continue to shift it over and add the carry, or compare the carry, XOR the carry with the current result they have from x and y, from XORing x and y. I'm hoping that made some sense. Does anyone have questions? You can tell me if you're like incredibly lost or confused. I can try. Ooh, okay. Didn't consider logical and. I know. It like shows up out of nowhere sometimes, but it's kind of helpful. I've never really done interview problems where they ask about bit manipulation before, like to like a very like this crazy of an extent, like in this really hard solution. But I have done like this problem before in an interview it's mostly about like knowing how to add binary numbers and like add them as strings. So if anyone has any questions, I think I'll stop the recording and I'll let you all go. There's a intro to Python workshop that's happening right after this. So I can send the link to the chat if you all have the emotional capability or mental capacity to handle that right now.